Hello guys, and welcome back to our Intel NUC 9 Extreme water cooling project. For those of you that have been following the project so far, seen the previous videos, you'll know that what we're trying to do is we're trying to water cool this compute element card and this RTX 3080, but not only that, we're trying to fit all inside this Cooler Master NC100 chassis. This is a tiny, small form factor chassis, so it's definitely not a simple project, but we are starting to make some headway. If you caught the previous video, you'll know that the idea now is to kind of make a copper heat spreader to replace the stock heatsink, and then we're using an Alphacool CPU block, and we're going to make or design a modified upper mounting bracket that is currently been drawn up now, so hopefully within a couple of weeks we should have that mounting bracket. But for now, you can see we've just got the Alphacool CPU block quite crudely zip tied to the original stock heatsink. That's kind of untested yet, because obviously we need to figure out how the rest of the system is going together. So today, first off, I'm going to look at how we're going to cool this, which shouldn't be too difficult, but it will be quite interesting because we've got one of Alphacool's new ice-block GPX, and this is for Founders Edition cards only. There's not a lot of footage out there of these Founders Edition cards being water cooled, so that's going to be quite interesting. So the first thing today is fit this water block to this Founders Edition RTX 3080. But before we dive into this, make sure that you subscribe to the KitGuru channel. If you enjoy the video, hit the like button and hit the bell button for notifications. And if you want to help support KitGuru in other ways, you can head over to the store, check out some of the cool merch on offer, and as always, you can jump on to the KitGuru.net website where you can catch up on all the in-depth hardware reviews and catch up on some tech news and some gaming news. So the Founders Edition RTX 3080, there's not a great deal of footage or information out there about how to fit a custom water block to them. These water blocks are still relatively new. This is the Alphacool ice-block GPX, designed for FE cards, so don't get that confused with reference. FE and reference are completely different these days. So we have the right block for the Founders Edition card. I've seen one or two disassembly videos, so I've got a rough idea of how this card is taken apart, or how to tear this card down. One of the main things with this card is it's extremely well put together by the looks of it. All of the screws or fixings, other than the screws on the backplate and one or two screws in the fans, rest of the fixings or rest of the screws are hidden underneath panels and just little bits that come off the card. I'm not saying that this is the perfect way to do it, or it's, you know, the official way to do it, but this is just how I'm going to approach it. So I'm going to remove the screws in this IO shield plate. I think they might be a T8 Torx. Yep, they're T8 Torx. The next step is to try and remove this section here. This looks like this comes off because you can see there's little bits in it, so you just lever that off with a flat bladed screwdriver. And then underneath here you can see these look like P0 Phillips heads, so I'll take 4 of those out. So removing those 4 screws has loosened off the back edge of this back plate, but it's still firmly fixed in place further down. So you can see there's these little covers here. These need removing. Now I've seen various other YouTubers and different channels struggle with removing these. I've seen them messing around with bits of glue on a stick, trying to stick it to the cover then lift it off. Seen people use tape as well. That's not a bad method actually, that seems to work. These little caps are actually magnetic, so I found the easiest way to remove them is just get a Stanley blade, put the blade in the little crack at the back, and you can quite easily just lever them off. Not as difficult as maybe some channels have found. Just really trial and error really to find the best method, and that seems to be it. Below these caps you've got another 4 Torx screws. These are tiny Torx heads. I believe these are a T5 Torx. IO shield has now come off the card completely. And by the looks of it, that should be everything that is holding this backplate on. So yeah, that just pops off. It's obviously stuck down a bit because it's got these thermal pads on the backplate. So that's that out of the way. You can see now we've got that backplate removed, you can just see how long the actual PCB is. When we get the Alphacool water block on there, this will be roughly the length of the card, and that'll save us some space inside the chassis, which is what we need. It looks like the only screws to remove now are these four that basically hold the cooler directly to the GPU die. There are a couple of connections to remove. There's one here, and one here. These are tiny, I guess. These are for the fan and for the lighting. So these small clips, you just have to lift the back of the connector up, and then hopefully we can just very carefully remove that ribbon cable. The same with this one, so just the fingernail under the back of the connector just to lift the locking mechanism, and again just very gently pull that ribbon cable out of the way. And then this one is slightly different. We need to move this metal retention spring or retention clip out of the way, so that just lifts out of the socket. Now we can remove the four screws on this retaining spring. So that's a T6 Torx. So we'll just try and remove these pretty evenly, loosening them off just one at a time, just a little bit. That's that out of the way. That's just like a leaf spring that creates the correct amount of mounting pressure. So now that all that is disconnected, all these wires are disconnected, hopefully it should come apart. Yep. That actually went pretty smoothly, and you can now see just how small these RTX 3080 Founders Edition cards are. They are really tiny compared to even the reference cards and the 20 series. Lovely compact design, ideal for this system, and it shouldn't be that much bigger when we get this Alphacool water block on. With this Alphacool block, you actually get an Alphacool backplate, some thermal compound, mounting screws, and some tiny see-through plastic washers, a bunch of thermal pads for the actual cold plate, and a separate set of thermal pads for the backplate. Because there's so many different size thermal pads, I've actually admitted defeat on this one and broke out the manual. So first things first, we need to install all the thermal pads to this GPU block. So I'll just get it the right way around compared to the manual. Start with number one. Next step is to get some thermal compound on the GPU die. So I'm just going to put some on and spread it around to make sure that we get good even contact. That looks pretty even, pretty well covered, so I'm happy with that. So now I need to lower this down, aligned with the screw holes. Screw holes are there, aligned. That should be in position. Then we need these spring-loaded screws and these tiny plastic washers, if I can pick them up, and tighten them up evenly and progressively. I usually like to do it in a kind of an X shape, just tightening each screw down a little bit at a time. So now we need to prepare the back of the PCB for the installation of the back plate. So that means installing more thermal pads. That's all those thermal pads installed. Now we just need to fit the back plate correct way around. So line it up with the screw holes, and then we have these long black screws that go in. Hold this in position, so put these in place. So there we go. That is the installation of the GPU water block completed. And now the card in total, including the backplate, measures about 209 millimeters. Looking at the old original stock heatsink, that was around about 290 millimeters. So we've saved about 80 millimeters looking at it by installing this custom water block from Alphacool. You can see we've saved a considerable amount of space at this side of the chassis. So hopefully, if my calculations are correct, that should just leave us enough room to install the pump rest combo that I have in mind. Because of the space restrictions inside this NC100 chassis, we're kind of limited to the options for a pump or pump rest combo. Now that we've fitted that GPU block, there is some space freed up at this side of the case near the power supply. We had a couple of ideas. The first one was to maybe use some small inline pumps. I wasn't too keen on that idea, and then Alphacool came to the rescue again with this ES reservoir. This is designed for 1U chassis, and it's ideal for this small form factor that we're using. So we've got a bit of space here, and this will fit just about perfectly there. I originally wanted to hard mount this reservoir to the casing of the power supply, but that was a problem. This top cover is really close to the PCB, so that's not really an option, or it's not going to be simple to do that. So for now, I've just used the self-adhesive Velcro. So there's one on the back of the res and a piece on the power supply. For now, it literally just sticks there with Velcro. If that doesn't become sufficient enough when the system's all built up, I'll look at a different option. You can mount this 1U ES reservoir onto a 2.5 inch SSD mount, so that might be something that I'll investigate if this Velcro isn't good enough. But when you press that on, it is pretty solid, so it might not be too bad, and hopefully the Velcro may give it some kind of shock resistance or noise absorption, so it might not be a bad idea. We'll see how that goes when we get the system piped up. So that wasn't too difficult. I was expecting to spend a bit more time on that, but it's probably all right. And because we can use that ES1U reservoir, that also means we can use a more powerful pump. So this is just a standard DDC pump, and that just fits straight on there. The only problem with this that I can see at the moment is these god-awful multicoloured cables that Alphacool insist on using. So they're going to have to be swapped out. I'm going to have to find power for this Molex. So that means I'll have to either add another cable to the power supply or try and take the power from elsewhere. I'd like to take it from an actual Molex from the power supply, because then you know it's getting the correct power rating, enough amps and what have you. We also have a tack cable as well. That might be a bit tricky wiring that out, but we have removed the stock fan, and that is a PWM fan, so I may be able to take a signal wire from the board to this tack cable, which will be useful because then we'll be able to hopefully adjust the pump speed as well. But I'll look at modifying those cables either later on or in another video. For now, I just really want to get the system built up and do some testing with it in this configuration with the custom loop fitted. I'll leave that for now. Oh, I've also just removed the sticker off the power supply as well. It looks a bit neater without that sticker on there. GPU back in, figure out the radiator mounting, and get this system piped up and just do some initial testing. I'm really curious to see how this performs with this water block just fastened to the top of the vapor chamber. So that is what I'm going to do. tubing from the pump to the CPU block, and then from the CPU block to the GPU is installed. I think it should be all right like that. Getting to this fitting was a little bit awkward, tightening it up, but I've managed it. Currently, we go out from the pump, and then from the pump into the input on the CPU block, and then out of the CPU block to the GPU. So we need to now connect up the GPU to the rad, and then the rad back to the pump res. Fitting a radiator inside this system was always going to be a compromise. I said right from the start that the radiator will probably have to be externally mounted. I've got a couple of options. I've got a 2x92mm radiator, and in here there's a 240mm rad, both 45mm thick. I'm going to start by trying the 2x92mm because that will fit to the fan mounting points on the top of the chassis. So the only problem I can see with that is I'm going to need some cutouts in the top here, obviously for the two outlets on the radiator. So just move that to the side, just pop the radiator on and line it up with the screw holes. You can just see through there that they're pretty well lined up. And what I've done actually is just marked out in pencil where I need to cut out this, so obviously the other one as well. I'm also thinking that to probably assist airflow or improve the airflow is just cut out the rest of this grill or whatever you want to call it, but try and keep in these fan mounting points so we got somewhere to fix the fan and fix the radiator too. So I think angle grinder with a fine blade on, we'll cut that out to begin with. Maybe just cut it all out now and see, because if I do end up fitting the 240 rad, I think I'll just have to cut all this out anyway and mount it a little bit differently, because the 240 rad basically is the same width as this top cover, and with the 240 rad I'll also have to remove this back handle or spoiler or whatever it is. So I'll try the 2x92mm first, do some thermal performance tests with that, see if that's up to the job. If not, we'll switch to the 240. Okay, I've cut out the majority of the material that's needed, and if I just lay this on top of the radiator now, you can see that should be clear of any tubing, and it gives me space to install the fans, and there's no restriction between the fans and the radiator for airflow. So that's almost done. But the only problem with that is you can see that it's left some really sharp edges and bits of fash that need to be removed by hand. So just going to finish that off with some files, smooth it down as much as possible. I'm not too worried about how it looks at the moment, because the whole case is going to have a custom paint job eventually. I also had to take a small amount out of this rear handle or spoiler or whatever it is, just so that I could slide the radiator back far enough. I'll get on with smoothing that down, and then after that it will be a case of fitting the radiator, putting the last bits of tubing in, and hopefully filling the system up, and we can do a bit of testing. Right, that's looking much better now. All those sharp edges are gone, and quick rub down now, and that will be ready for painting. That'll be something we'll look at in the next video. We're painting this chassis and doing some mods to the case as well. If we just put the radiator on there again, that looks pretty good. There shouldn't be any interference with the fittings, and we'll have a nice clean and undisturbed airflow to the radiator. So get this radiator actually mounted onto this top panel, fit a couple of fans, and should be ready to then pipe up the rest of the system, fill it up with fluid, and see what happens. So as you've seen, it wasn't easy filling the system up and getting all the air out of it, but that is done now. I'm pretty confident that I've got as much air out as possible. I've tried to have a look for leaks, but it's very difficult, so just fingers crossed that there's no leaks. The pump's just connected up to a separate power supply for now, just until I can put the Molex onto the Seasonic power supply that's inside the system. Power the pump on first. So the pump's just running at its fastest speed at the moment because I've not got the tack cable connected up, but it's not too loud. It is audible, but it's not loud at all. So I'm tempted probably to run that at its maximum speed. If this was, I don't know, a gaming machine or something like that where you might have headphones on, but I'm still going to try and hook up that tack cable to the spare fan connector on the compute element. So let's turn it on. Press F2, jump into the BIOS. So F2 in the BIOS. Look in the power section. The package power limit, the sustained, so the long duration power limit is at 65 watts, which is the same as we tested the system when it was stock, and then the short duration, so the power limit 2, that's at 107 watts. So that's just stock settings. And cooling, the fan control is set to cool, which it was as stock, and the primary temperature sensor is the CPU. So nothing's been changed in the BIOS for now. Everything's as it was when we had the stock cooling on. So that's all the same. So now we can see if this water block attached to the vapor chamber makes any difference. So just to recap, this isn't the final or finished product. Currently the Alphacool CPU block is just zip tied to the original vapor chamber. Just the vapor chamber is going to be replaced by a solid copper heat spreader connected directly to the CPU die. So system's booted up and it's idling. There's not much CPU usage going on at the moment. Idle temperature's looking like 33 degrees, so low to mid 30s, which is a promising start because with the stock cooling on, the idle temperature was 40 to 45 degrees. Temperature we're going to be keeping an eye on is the CPU package, but also keep an eye on the individual cores as well. So it looks like the idle temperature stabilized around 37 degrees C. Let's start up Ada 64. Doesn't look like there's any water pouring out of the PC, so that's good. So we've highlighted stress CPU, stress FPU and stress cache. Let's click start and have a look and keep an eye on the temperature. Package power at the moment is at 102 watts. That's the short duration power. CPU temperatures 83 degrees C, which is nothing out of the ordinary. CPU frequency was between 3.8 and 4 gigahertz across all cores. And now we've dropped down to the 65 watt power limit, and the CPU frequency is 3.25 across all cores. Temperature's looking really good actually. We're down at 65 degrees. At stock we were up at 77, 78 or 80 degrees. So I'll leave this running for 30 minutes, come back and have a look at that CPU temperature. So that stress test ended, and after 30 minutes the average CPU temperature was 73 degrees C, which is only about 5 to 7 degrees lower than with the stock cooling. But one thing that is noticeable, and I've just started the stress test back up again so you can see, is the noise levels of the system. So that is mainly what you can hear there is pump noise. Fan noise is virtually silent. The fans never really got over 1100 RPM, so that is quite impressive, although I am a little bit disappointed that we've not seen a bigger decrease in the CPU temperature. But saying that, this is only with the CPU block zip tied onto the stock vapor chamber, so maybe when we get our proper final solution, hopefully there's an increase. If not, I'll try upgrading that 92 or that 2x92 mil rad up to the 240. But for today, that is all we've got time for. In the next video, I'll have to strip the system down again, prep the case for painting. There's going to be a bit more modding of the case as well. Maybe look for a way to add more fans to the system. Potentially could add a couple more fans on the top for push-pull airflow, and then maybe stick some fan grills on top of there. Not sure about that just yet. I don't know whether I want to make this any higher because it is getting bigger and this is a small form factor build. We also got some action going on with this side panel. There's going to be a Intel 6 Pillars logo laser cut out of a panel, and probably some acrylic and some custom lighting if we can squeeze it all in. So make sure you keep an eye on the KitGuru site for the next episode, and while you're at it, make sure you subscribe to our YouTube channel, and don't forget to hit the like button and hit the bell button for notifications. And as always, you can head over to KitGuru.net where you can catch up on all the latest in-depth technical reviews, and you can catch up on some tech news and some gaming news. Thanks for watching, guys. I'll see you next time.